of. So for number 2, if we are writing the slope-intercept form of the equation of a line through this point and this slope, if this were a normal slope, we would be using our y minus y1 equals m times x minus x1. But this slope is undefined. There's only one type of line that has a slope that's underlined, and that's an x equals. So we're going to look at our x value and write that as an equation. That is it. If it's at 0, you can do the same thing for y, or use your y minus y1. Questions on that? Okay, number 4. Find the x and y intercepts of this given line. You had to put 0 into one of the variables. It did not matter which one you did first. And solve. Done. Please stop talking. And then write them as ordered pairs. So the y would be 0, 2, and the x would be negative 4, 0. So you should have the work for both as well as both intercepts in order pairs, as ordered pairs. Questions on that one? And then number 5, we're solving this equation for r. We need to get rid of pi by dividing on both sides. Get rid of the squared by taking the square root on both sides. So the square root of a over pi equals r is our final answer. Questions on that? Make sure you are holding on to this check by answer sheet. Once we do 15, you're going to turn that in. Look at your notes on your desk. As I mentioned before we started the line of best fit stuff, this is really 2 short units combined into 1. So we're going to talk about direct variation, finish that, and then start inverse variation. So first, let's talk about definitions. A direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Direct variation equations are written in the form y equals kx. So this is always going to be the equation. Kind of looks like our slope-intercept form should, because it's similar. The ratio that we're talking about, so I'm going to do this to this equation just in case you forget where this comes from, and it's going to help us do this next part, is the k. We're solving for k, so we would divide both sides by x. So k, or what would be similar to our slope, is going to be y over x, which is similar to our slope. So when we're finding our constant k, it's also called a constant of proportionality, we're going to be dividing y over x. If we divide these numbers and it is the same throughout, then you have a constant. It is k. It is direct. If it is not constant throughout, then it is not. So we're going to test that theory in some of these. So with each of these, we're going to divide y by x. 4 over 1, 8 over 2, 12 over 3, and 16 over 4. When we divide those, what do we get?
4.
For each one? So because 4 is our constant, it is the answer for each one. write the equation. So it's going to be y equals 4x. Question so far? So if you could do this with order pairs or a table, if the constant is always k, or the k is constant throughout, then that is your k, then you can use your direct. But when we do that here, divide y by x, skip the 0 over 0, but what are the other ones equal? This one was already 2 over 3. 0 over 0 wouldn't give you an answer, so you would probably think, oh, we don't have a constant k because it's not constant throughout. But if we think about this on a graph, if I was counting my slope and started at 2 over 3 and then went down 2 to the left 3, I would end up back at 0, 0. So even though this won't equal 2 over 3, thinking about it on the graph, it would. So the constant is still the same. One other way you would know that 0, 0 works is if this is like our slope intercept form, what would our y-intercept be? So if you see 0, 0, that means it is direct. So our equation would then be y equals 2/3 x. So keep that in mind. It may not always give you the constant, especially if it has 0, 0. Questions so far? This next part, we're just going to identify, is this direct or not, based on does it look like the equation that we wrote down before? Is this direct? Yes. So because it is, what is the constant of variation or proportionality? 3. What about 6? So you're saying it is direct? Yes. And the k value is -4 over 5. What about 7?
No.
No, there's no x, it can't be. 8, we would have to solve first. Divide everything by 2. Would that be direct?
Yes.
Yes. What would the constant be? 5 over 2. 9. Why not? These are full equations. What's different between this and the ones that we said yesterday? It's, what did you say, James? Not necessarily. What were you about to say, Heather? The 4 should be in front of the x, okay. But something about this -4 is not right.
It's the y.
It's the y-intercept. What should the y-intercept be? 0. It's not 0, so it can't be direct. So if you see something that is not 0, a y-intercept that is not 0, it is not direct. Right, 10. Yes. And the k value is -1. If I divide both sides by 2 for 11, and I leave it like that, would that be direct?
Yes. No.
You had it right the first time. Because this can be rewritten as what? So if you see something like this that is still direct, because you can rewrite it. If you see something in this format where it has variables or coefficients for both of these, you can automatically assume it's a no, but we'll solve it just to make sure. because we're dividing this by 2 and this wasn't 0, this is going to give us some y value that is not 0. So it would not be direct. What about 13?
Yes.
Yes. Because if I subtract this over, I still get y-intercept of 0, and I have my constant. Right, so that is how you can tell if something is direct based on the equation. Now we're going to talk about how to find that from a graph. So when you finish, go on to the next page. So in your graph, in order for it to be direct, the k has to be constant throughout all of your points, like your slope, and your y-intercept has to be 0. Is 14 direct? Yes. And then what would your k value be?
3/2.
3/2. Would 15 be direct?
No.
Why not?
Y.
The y is not 0. The y-intercept is not 0. 16?
Yes.
Yes. What is the k value?
1/4.
Negative 1/4. And 17? Yes. And what is the k value? 3/3, which simplifies to
1.
Alright, so now that you know how to find if it's direct or not based on the equation in the graph, now we're going to actually use that to find missing values, which is really what you use direct for. What's nice about this is we're going to be using the equation we have, y equals, I'm going to rewrite it up here, y equals kx, and k equals y/x. We're going to be using those two. So in this, we have a y and an x given. So we can divide these two to find k. So that our k value would be -2. Then we're going to use the other ordered pair in our equation to figure out whatever's missing. So we don't have y, so that's going to stay y. Our k value is -2. Our x is -6. This is k. So then our y value would be 12. To double check that, how could I double check that actually? Yes. What else? How else? Using something we just did. Put it into where? Okay, and do what with it? Put it into the missing y, yes, and do something with it. Do what? So I could graph it, yes. I could also just see if this k value is the same. If it is, then it worked. If it's not, then I did something wrong. Okay, let's try one with an x, and then we'll do some of these other ones. So same thing with 19. You have an x and a y. Find your k value by doing 16/4 y/x, so that your k value is 4. Then in our new equation, we have, it should be y equals kx. We have y, which is 24. Our k, which is 4. We don't know x. So then to solve for x, divide both sides by 4. So that x is 6. So if I were to check it, 24/6 does give me 4, so the k value is the same. Questions on this so far? 22 through 25 are very much like these, except now that this has more words. So let's try 22. If y equals negative 18 when x equals 3, find x when y equals 30. This is just like the one we just did. We're trying to find x, but we have to find k first. So how would we do that? Negative 18 over 3. Okay. And then how would we find x? Equals negative 6x, and divide both sides by negative 6. So that x equals negative 5. And then if I were to double check, 30 over negative 5 does equal negative 6. That works. Okay, let's do one where we have to find y. Those of you talking probably shouldn't be. Let's do 24. What would be our first step? 10 over negative 4, which would become I heard things, but I didn't actually hear what you said. It would be negative, I heard a 2 and what? 5. There we go. So negative 5 halves, that will be our 5. What's our next step? Set up the equation. How would we set it up? Y equals negative 5 halves times 12. After you find your k, you're always going to put it back into your y equals kx. What is your y value? Negative 30. And 12 over negative 30 should simplify to negative 5 halves. So you guys could check that if you so choose. Right. Are there any others on this page you want to see, do, go over, have questions about before we go on? Now would be the time to ask if you're confused. Or we're talking and didn't get instructions. Okay, on the next page. You guys only have this half. This will be when we do inverse. But when we talk about direct, think about this as like a positive trend or a positive correlation. One variable goes up as the other variable goes up. As one variable goes up, the other variable goes up. So the more you study, the higher your grade is. But these can also go down together as well. The less you study, the worse your grade is. They either go up or go down together. So we'll do a couple of these. What's nice about this is that how we solve it is really just like what we just did. There's just more words. So we have to find important things, and then everything else will be the same. So let's read through it. Read it with me either on the board or on the paper. The sales at a baseball game vary directly with the number of people attending. If the sales for a game are 12,000 when 800 people attend, determine how many people attend if the sales for a game are 15,000. So, important things that you see first. 12,000, 800 people, 15,000. And then there's some questions in there. How many people attend? And then is there any word that sticks out that maybe correlates or goes with what we're talking about? Varies directly. That word is important. It will always say some form of varies directly, directly proportional, something like that to tell you this is direct variation. You just have to know those words. Okay? Then this next part will always apply. Whatever comes before the words vary directly is your y. The number after is your x. decide as defining them or just label them in there. Either or doesn't matter, but you have to do one of those. So then if we know the sales are 12,000, that's our Y, and we know the number of people is X, that is how we find our K. We could think, because it's like slopes and it's real world, we could think about this like $15 per person. Since this is dollars and this is number of people. That's just tying into things that we already know. So we now have our K. Now we can use our equation. I'm going to write it again, y equals kx, just so we remember what it looks like. We are looking for how many people. So would that be y or would that be x? X. We are looking for x. We have our y. How would we set this up? 15,000 equals 15x divided by 15, and our x equals 1,000. 1,000 what? We need to put labels because this is real life, real world. So since we know how to solve for a missing variable, it's really the same. We're just putting which one goes together. Adding extra words. What questions do we have so far? Let's do number 2. Going back to the up or down together, the more people that attend, the more money they make. The less people that attend, the less money they make. So they go up or down together. All right, let's read through number 2. Ounces of medication vary directly with the weight of the patient. If a 120-pound adult requires 3/4 of an ounce of medication, how many ounces are required for a 200-pound adult? What is important here? Okay. Varies directly. Someone else said pounds. So 120. Okay. 200. 3/4 ounces.
How many ounces?
How many ounces? Alright, so again, whatever comes before the word varies directly is your Y. Whatever comes after is your X. So ounces is Y, weight is X. So you want to go through and label each one. So then what are we looking for, X or Y?
Y.
Y. So since ounces is Y, that's what we're looking for. The biggest thing with this is knowing what you're solving for so you don't solve for the wrong thing. Right. How would we find our K? Would that be our Y over our X?
3/4.
3/4 over the 120. But we're not going to put it in as a fraction. We're going to change it to 0.75 over 120. So that would be ounces over pounds. Calculate that. Tell me what that is. 90. Everyone get 90?
I got a decimal.
Okay. I was going to say, no, I'm pretty sure it is a decimal. Double check that. What is the decimal?
0.0065.
I think you did it the other way.
Yeah.
No. Because I was like, I'm pretty sure it's supposed to be a decimal. Because 90 ounces of medication per pound is a lot of medication. So also when you're doing these problems, think about, would this make sense in real life? Does this make sense? Because if no, it probably won't. So double check that. Right? And then we're solving for y. How would we set this up?
200 equals 0.65.
Now is that our x? I'm sorry, is that our y? Would it be 200 equals y equals, we don't know y.
200.
And then that's space, because my marker was too big. So we're looking for y. We have x. We have our k. Let me rewrite that so it's not good. So then what would that be? I didn't mean to do that. 205? 2.5. 2.5 what? Ounces.
I got 1.2.
Yeah, I got 1.2.
Wait, no, yeah.
Okay. So we put in the wrong thing. Okay. So if you get something different, please say something. Do we have any questions on how to set this up, how to solve it? Let's go down to number 5. And then I'll ask for any others you want to see to go over, and then we'll switch gears. Alright, so for number 5, the income of a computer analyst varies directly as the number of hours worked. Excuse me. If the analyst earns $256 for working 8 hours, find the constant of variation. What's important here?
$150.
$256.
8 hours.
8 hours. What are we looking for? Okay. So then in this, we know that the word varies directly is here. So the income is our x or y. Y. And the number of hours worked is our x. And if we're looking for the constant of variation, how would we find that? 256 over 8, which is 32. So that would be like $32 per hour. Did it ask us to find anything else? No, so that's it. Don't do more than what it's asking you to do. If it says find a constant, that's it. Are there any others on this page we want to see you go over before we switch gears? 4. We'll do one of these and then go on to inverse, and then if we have time, we'll come back. Right. For number 4. Acreage. Okay. Varies directly with the production in bushels of wheat produced, and a 20-acre field, 300 bushels of wheat are produced. At this rate, how many bushels will be produced in a 50-acre field? So you got 5 times less. Okay. What's important here? 20-acre field, 300 bushels. How many bushels will be produced in a 50-acre field? See that word varies directly again. So what is y? What is x?
Y is acreage, x is bushels.
Bushels. So 20-acre field.
Will it ever be a problem if it doesn't say very directly?
There may be an example where it gives you the scenario and asks, is this direct or inverse? But you'll be able to see them either going up, down together, or when we talk about inverse, opposites. Right, so acreage, y, x. What what are we looking for, x or y?
Y.
Not y. Is that the
X.
answer? It is x. Alright, to find our k, we would do what?
20 equals
It should simplify to 2/3. Alright, and then to find our x, how would we set that up?
It wouldn't be 2/3 because it's 20 over 300.
Right, because then it would be 2 over 30, which would be 1 over 50. Remember. How would we set up finding x?
50
equals 1 over 15x. We could divide by the 115. What is another way we could solve that? Multiply by 15. Flip it, multiply by the reciprocal. But at this point, we should be multiplying by the reciprocal, not dividing. What would that be? 150? 700. What? And inverse and direct are opposite. So direct had a constant ratio. What do we think this one is? So ratio is a division. So opposite of that would be multiplication and product. Between all ordered pairs, the inverse variation equations are written in the form y equals k over x.
Which one do you think is harder, inverse or direct?
That depends on what you do. Finding from a graph. It depends. So then, the word problems, I think they're really the same. Alright, just like we did before, if we were finding the k for this, how would I solve this equation for k? Multiply both sides by x. So k equals y times x in this case. So when you go to take your quiz and test, your goal will be to not confuse the two, not mix them up. Direct is you are dividing to find k, but your equation is multiplying. Inverse, your equation is dividing and you are multiplying to find k. They're opposites. So just like with our constant k before, if we multiply all of these and they give us the same constant, that is our constant. So if we were to multiply these three, we would get 20. K value is 20. How would we write that in this format?
Y equals 20 times x.
That times
Equals 20x.
20 over x. What about in this table? Multiply your x's and y's together. What do we get for each one?
Negative 12.
Negative 12. Sorry, for this table, not the order quiz. The k is constant, so how would we write this as the equation?
Y equals negative 12x.
Okay. Now, you are not going to need to graph this, but I'm going to show you what a graph looks like. So if it asks you, is this inverse or direct, you know what it looks like. Right. So in this example, we have a constant that is 16. That means we multiply to get 16. Tell me all the different ways we could multiply to get 16.
4 times 4.
4, 16, 1, 2. That's it. But I'm also going to do these in reverse. So 1 and 16, 2 and 8, 4, 4, 6. Now I'm going to graph all of these points in however order you want. These are counting by 2s, so the 1s will have to go in between. So we have 4, 4, 16, 1, 8, 2, 1, 16, and 2, 8. We make this curved shape. So connect all of the points and draw arrows at the end. This is only half of it though, because we have a positive number. How else can we multiply to get a positive number?
Multiply by
Positive times a positive will give you a positive. How else? How else can we get a positive number? How else can we multiply to get a positive number? Negative times a negative. So same numbers, but now negative. I'm going to do this in order to learn. So take the negative numbers and also plot those. Negative 1, negative 16, negative 2, negative 8, negative 4, negative 4, negative 8, negative 2, negative 16, negative 1. And do the same thing. Connect them and draw them. This shape, yes. In a second, yes. This shape is called a hyperbola. You'll learn about that in pre-calc algebra 2 if you go onto those. Again, you don't need to know how to graph this shape, but you need to recognize that this is the shape for an inverse variation. So if you see something like this, this is clearly not direct, that is a line that goes through the origin. Once you have finished this, go on to the next page. You're not doing the graphing, but look at the bottom, left to the right. This part is very similar to what we were just doing in direct, except we're using the inverse variation, which I will rewrite up here. So then for number 7, our first step is to find the k value, which we would do by multiplying these two together. 12 times 14, you get
That's not the equation we have.
Yeah, it says 4 times 12.
Rather missing. What's 12 times 14? Something in here.
I don't know before you touch it like that.
Focus!
It's like 22.
And in the next equation, we're missing y, so we would need to set it up using our inverse. Y equals k over x. Figure out what that is.
-7.
We all get -7.
Where did we get 24 from? 24.
From the,
How could I double check this?
That's not.
Yes, multiply -7 by -24 is equal to positive 168. Alright, let's try the next one. Let's actually try 10, because that's the only one that's missing x. Alright, these have been swapped, so the second ordered pair has both x and y. That's what we're going to use to find k. Multiply those two. Not 66, negative 63. You were close. Set up your new equation. We have y but not x. So -7 equals -63 over x. How do we solve for x? Multiply by x. Multiplying by -63 would not do anything. It would not get rid of x. Stop talking. And then you have to divide. So the x equals
8 plus 9.
We'll do one of each of these and move on to the word problems. 11. How would we find k?
Wait.
For number 11.
Oh. 9 over 9.
Are we dividing or multiplying 9 and 6, -6? We get -54. How would we set this up? Equals. So just like this one, multiply both sides by x. Divide both sides by 3. X equals -8. Find x. Let's do 14. How would we find k? -8 times -7, which is close. 50, it is positive. 56. How would we set this up? -4 is x. Y equals 56 over -54. Y would equal yes, but I meant 56 over -4. I combined the two. -14. Alright. Flip that single page over to the back. At the top, this is where the other box is. In situations where one variable increases, the other decreases, or vice versa. The more you travel, the less gas you have. Trying to think of another one. In 1 second. But think about it like they're opposites. They don't go up and down together. Alright, so start reading number 7. Go ahead, Rose. What did we find is important there? The 2 cities part is not really important. The 3 hours, yes.
Average speed is 60 miles per hour.
That is important. Along the average speed.
70.
And the 70. Okay. And the fact that it says varies inversely. So varies inversely or inversely proportional will be the words you see. The rules are the same here. Whatever comes first before this is still y. Whatever is after is still x. So that part has not changed. So that means our number of hours is y. Our speed is x. We are looking for x or y. Y. How long? Time. So then, to find our k, we would do what? $65 times 3, which would give us. Now, in these cases, we're not going to put like a something per something because that was more per slope. And then to set up our equation, what would that look like? Over 78. Maybe some decimal, but that's fine.
1.346.
Is that what we all got? Is 195. So that's going to change this. And this one. What 5 what? 1 hour. When you get your answers, think about, would this make sense as a decimal? Can hours be decimals?
Yes.
So we can leave it as a decimal. That would be too long. That's a lot. That is a lot. Let's do. I think these are all finalized. So we can do one more. I'll let you guys choose 8 through 10. Pick one of those. 9, I heard, so we'll do that one. So start reading that one. What's important there? Varies inversely. What else? The length is 18, and then we have to find it when it's 8. What else? The width is 4. What are we looking for? The width. Right? So the width is going to be x or y? Length is x, so every time you see width, y. Length is x. Find k by doing what? 4 times 18, which is 72. And then how would we set this up? Y equals 72 divided by 8, which is 9. This doesn't have I don't think it actually said inches, but if it did, you would put that. Alright, let's do 11 and then we're done for today. The time it takes to bake a turkey varies inversely with the oven temperature. It takes 3 hours to bake a turkey at 300 degrees. Find the constant of variation. What's important?
Varies. Inverse.
It varies inversely. What else?
3 hours.
3 3 hours. What else? 300 degrees. What are we looking for? So how would we find that? 3 times 300. And that would give us? You're done. Nothing else. So you have about 21 minutes, something like that, to practice. Work on these delta maths are due next Wednesday. Remember, you have one that's due on Friday, tomorrow. On Monday, we're going to review, and you're going to take your quiz. So keep that in mind. So whatever you do not understand from this, you need to be asking questions. Use the rest of the time to practice. You can move around, asking questions.